It's hard to imagine, right? Ice used to be a luxury, a deadly, highly coveted luxury. Today, we're unraveling a pretty incredible historical mystery: how a dangerous, incredibly rare commodity transformed into this invisible force that literally keeps our modern world alive. We're talking about a story filled with tragedy, ruthless business empires, and some absolutely brilliant scientific breakthroughs. To really grasp the gravity of this story, we actually have to plunge right into a sweltering life-or-death crisis. Imagine this. It's the summer of 1841, Florida. The temperature, a brutal 40 degrees Celsius. And a local doctor named John Gorey is facing an absolute nightmare. Yellow fever, which terribly was known back then as the black vomit, was just wiping out entire families. His small infirmary is packed with patients, jaundiced and literally burning alive with blistering 40-degree fevers. Now, with zero modern medicine to cure this, Dr. Gorey came up with a desperate, radical treatment just to ease their suffering. He actually suspended pans of ice from the ceiling, letting that cool, dense air sink down over his burning patients. But here's the catch. Ice wasn't just frozen water back then. The locals called it white gold. It was a heavily monopolized commodity shipped from thousands of kilometers away. Just a few days' supply would cost more than what most people made in a year. And as Dr. Gorey's supply inevitably melted away, he was left entirely helpless. He just had to watch his patients suffer and die. So why was ice so impossibly rare? Well, for that, we have to look at the origins of a bizarre global monopoly. Section 1. The birth of the Ice King. This whole empire was built on a chaotic, almost ruinous journey. Back in 1805, a 22-year-old Boston merchant named Frederic Tudor traveled to the Caribbean with his brother. They both caught a severe fever, and tragically, without ice to cool down, his brother died. Driven by this really painful memory, Tudor became obsessed. He was determined to bring northern ice to the tropics. In 1806, his very first shipment to the West Indies completely melted away on the docks, a total failure. By 1809, this obsession had plunged him $40,000 in debt. That's over $1 million today, by the way. The guy was hiding from sheriffs on his own ships and actually went to debtor's prison twice. But he just refused to quit. Finally, by 1833, he achieved this massive triumph, successfully shipping ice on a grueling 4-month journey halfway across the world to Calcutta, India. So how exactly did he turn a melting failure into a global empire? Well, first, he had to create the demand. People in the tropics were actually really suspicious of cold drinks at first. They thought the sudden chill was dangerous, maybe even deadly to the body. So Tudor did something incredibly smart. He just gave the ice away for free to bartenders. He proved that once a person tasted a perfectly chilled cocktail, there was absolutely no way they were going back to a warm one. He also introduced ice cream to the West Indies, which, as you can imagine, was an absolute sensation. Then he got to work slashing his costs. He figured out he could use free sawdust from local sawmills as a highly effective insulator for his ships. And out on the frozen New England lakes, he replaced those dangerous manual ice saws with horse-drawn plows. Ultimately, he managed to drop the extraction cost from 30 cents down to just 10 cents a ton. That ignited global demand like wildfire. But the physical reality of shipping frozen water across the blazing equator, that remained a huge hurdle. Section 2. The ancient science of preservation. The exact science Tudor relied upon really comes down to surface area. Think about it like this. If you take 8 single scattered ice cubes and compare them to one megablock made of 8 tightly packed cubes, those scattered ones are going to melt significantly faster. The main way ice melts is through heat conduction right on its surface. Even though the total volume of ice is exactly the same in both scenarios, the scattered cubes have double the exposed surface area. So the secret to keeping ice frozen for months? It's simple. You just pack it together as tightly as humanly possible. And this brings us to a foundational rule of physics, the square-cube law. Essentially, as the size of an object increases, its volume grows much faster than its surface area. Interestingly enough, this is the exact same mathematical principle that recently allowed a massive 30-meter-high pile of snow in Helsinki, Finland to survive a record hot summer. It's wild, but it works, and it's the exact principle Tudor banked his entire fortune on. By cutting massive, uniform blocks of ice, he minimized the surface area exposed to the warm air, locking that cold deep inside the volume of the block itself. But here's the thing. Tudor didn't actually invent this concept. He borrowed heavily from 2,300-year-old Persian techniques used by King Xerxes way back in 500 BC.
Out in the desert, the ancient Persians would freeze water in shallow pools overnight. Next, they'd pack that ice tightly into a deep pit, taking advantage of the fact that cold air sinks. Finally, they'd seal it in a massive, thick-walled dome that was specifically designed to funnel warm air up and out. And Tudor, he successfully replicated this exact ancient architecture right inside the wooden hulls of his ships, elevating the ice away from the meltwater and insulating it completely from the outside world.
Section 3. Building a global cold chain. With the physics mastered and his supply line secured, Tudor became known worldwide as the Ice King. His success basically birthed a multi-level industrial network that completely rewired human geography. By the 1860s, what was once this rare luxury for kings became a daily necessity. We started seeing insulated ice boxes popping up in ordinary kitchen corners. This actually created a massive cultural phenomenon, the daily delivery by the Iceman. It sparked an entire genre of popular songs and lore at the time, but more importantly, this cold chain completely transformed human diets. Regional produce from, say, California or Florida could suddenly be shipped inland without rotting. In fact, that's exactly how iceberg lettuce earned its name. It was shipped across the country heavily covered in crushed ice just to keep it fresh and crunchy. But honestly, nowhere was this revolution more dramatic than in the meat industry. Before the cold chain, if you wanted fresh meat in New York, you had to ship live, noisy, dirty cattle by train directly into the city center to be slaughtered right there. It was incredibly inefficient, not to mention unsanitary. But the invention of the chilled rail car, that changed everything. Meat could now be processed out in the Midwest and shipped fresh. And the numbers here are just staggering. Chicago, which became the new meatpacking capital, skyrocketed from a population of just 30,000 to 1.7 million. New York City's beef shipments went from 2,400 tons to 63,000 tons in just 4 years. And because they were no longer paying to ship the inedible parts of live cows, urban meat costs dropped by 39%. The cold chain literally cleared livestock out of the cities, completely paving the way for modern urban development. Section 4. The Artificial Ice War. Now keep in mind, this entire billion-dollar cold chain relied purely on natural ice harvested from lakes. But remember Dr. John Gorey, the man desperately trying to save those yellow fever patients? Well, he decided the world needed to be freed from the Ice King's monopoly once and for all. He spent years trying to manufacture ice, and he finally stumbled upon a brilliant thermodynamic breakthrough. Step 1. He compressed air with a piston in a cylinder. Now, basic physics dictates that compressing air raises its temperature. Step 2, he piped that hot, high-pressure air through a bucket of cool water, bringing its temperature back down. Step 3, he rapidly released that high-pressure air into a second cylinder. Because expanding air absorbs heat, the temperature of the air absolutely plummeted well below freezing. Finally, step 4, he used this freezing air to chill a tank of liquid salt water, into which he lowered metal molds of fresh water. Gorey had literally created the world's first artificial ice machine, utilizing a perfectly reversible physics process. He had actually achieved the impossible. He could make ice in the middle of a blistering Florida summer. But Frederic Tudor, our Ice King, actually had spies in the audience during Gorey's public demonstrations. Recognizing the ultimate threat to his natural ice empire, Tudor went on the offensive and launched a ruthless smear campaign. He paid off newspaper editors up and down the East Coast just to mock Gorey. The headlines were brutal, screaming things like, "There's this crank that thinks he can make ice as good as God Almighty." And sadly, it worked. The public completely turned against this godless artificial ice. Gorey's patents went absolutely nowhere, and tragically, he died alone and penniless of malaria, suffering from the very same fevers he had dedicated his entire life to curing. But you know, science cannot be suppressed forever. A Scottish engineer living in Australia named James Harrison recognized the sheer genius in Gorey's work, and he found a way to make it wildly more efficient. Instead of using air, Harrison used a highly efficient phase change liquid. And this process, it's the exact same thermodynamic loop powering the refrigerator sitting in your kitchen right now. Step 1. A liquid is held under high pressure. Step 2. It passes through an expansion valve, which drops the pressure instantly and turns a portion of it into a gas. Step 3. As it boils into a gas in the evaporator coil, it requires energy, so it violently absorbs heat from the surrounding environment. That's what creates the cooling effect. Step 4. The gas goes to a compressor to be pressurized. And step 5. It pushes through a condenser coil outside the box, releasing that heat into the room, turning back into a liquid and starting the cycle all over again. Harrison's machine was a massive commercial success. It was manufacturing 3,000 kilograms of ice a single day. And what truly tipped the scales in this whole war was a pretty dark, ironic twist brought on by the Industrial Revolution.
Tudor's so-called God-made natural ice, it actually became a deadly biological hazard. Factories and farms were dumping raw sewage and chemicals straight into the very lakes and rivers where that natural ice was being harvested. People were unknowingly consuming this heavily contaminated ice in their drinks, which led to devastating outbreaks of cholera and severe food poisoning. Suddenly, the godless artificial ice, manufactured on demand with clean, sanitary water, well, it wasn't a sin against nature anymore. It was a literal lifesaver. Society eagerly and quite frankly necessarily embraced the machine just to survive.
Section 5. Refrigerating the Modern World. The transition was incredibly rapid, and it was absolute. By 1944, artificial refrigeration had taken over 85% of homes. Now, it's really easy to think of refrigeration as just, a convenient way to keep your lettuce crisp. But what humanity truly learned was how to control thermal motion right down at the molecular level. And that unlocked the modern world. Think about it. The cold chain makes the safe transport of life-saving vaccines, blood donations, and insulin possible. It preserves the biological samples we need to make PCR testing viable. And beyond medicine, the exact same thermodynamic principles that Gorey and Harrison pioneered, they allow us to cool things down to near absolute zero. That is literally what powers the supermagnets in MRI machines, the Large Hadron Collider at CERN, and the incredibly sensitive sensors on the James Webb Space Telescope. All of which leaves us with a pretty lingering question. What would our modern world look like today if a desperate doctor and a ruthless ice king had never chased the impossible dream of making ice in the dead of summer? From a dangerous, deadly luxury to the foundational bedrock of global food security, advanced medicine, and even quantum physics, it's a fragile, temperature-controlled reality that we rely on every single day, hiding right there in plain sight.